Bismillahirrahmanirrahim. Today I'd like to talk about rational inequalities like the one that you see before you over here. A rational inequality is an expression where you have a algebraic expression in the denominator here in conjunction with a inequality symbol like you see over here, less than. So this is a rational inequality. To solve these, we have to know some basic principles. The first of these is the concept of setting these inequalities to look something like this. So when you're solving these inequalities, you want to have it in this format, where on one side you have 0 and on the other side you have the remainder of the algebraic expression. So in solving these, and these fortunately are not going to be very difficult ones for us, we're going to want to change or manipulate all of these rational inequalities in this format. In however complex they are, you want to make sure there's one expression over here and then some inequality expression, and there's 0 on the other side. The second thing that we have to appreciate is the following. When we say that a certain number, let's say p, is greater than 0, that's basically another way of saying that p is a positive number, correct? And similarly, if I say I have a certain number, let's say n, and n is less than 0, that's basically another way of saying that n is a negative number. 0, if you recall, is neither a positive or a negative number, it's just a neutral number, so to speak. So when we say anything, whether it be an expression or a number, is greater than 0, then we are basically saying that that number or that expression is a positive number or expression. And when we say a number such as n is less than 0, we're basically saying that that number or that expression is a negative expression or number. So when we have something like this, we're basically saying whatever x is, when you replace the x in this equation, you substitute x in this inequality, the resulting fraction is less than 0, or it's a negative fraction. So that's what we mean. So this is the first important concept that you have to understand. The second important concept that you have to understand is that when we have a fraction, for example, if I have a fraction that looks that's such a simple one such as this, a over b, okay, and if I say that fraction is less than 0, like I have over here, then there's really only two ways that this can be. One scenario is that one scenario is that a is a positive number and b is a negative number, because a positive number divided by a negative number will give you a negative number, and that would be less than 0 over here. A second way that this can occur is that if the numerator, a in this case, is negative and the denominator in this case is positive, when both of these conditions are satisfied, the numerator negative and denominator being positive, then only then will this be less than 0, right? Because a negative divided by a positive is a negative. In the same way, if you have a fraction like this, a over p, and if it's greater than, or let's just say equal to in this case, to make it a little bit more trickier, if it's greater than or equal to 0, then there are only two ways that this can be. That is, when we say this, a over b is greater than 0, that means, in other words, saying this is a positive result in the end. A over b is a positive result in the end. The only way that this can be is that if a is positive and b is positive, that is, they're both positive, or the other way that this can be is that a is negative, the numerator is negative, and the denominator is negative, and negative divided by negative is a positive number, and it will be greater than 0, correct? Then finally, to add to this, the nuance of this equal sign over here, a over b is equal to 0. The only way that that can be is if a is 0. B can never be 0 because division by 0 is not defined. Since a over b is greater than or equal to 0, it means this can happen in this scenario, or when a is equal to 0, correct? So there are three possibilities that this will occur to be true. And so we use these two principles, these two concepts, to solve rational inequalities like this. So in using those principles in solving this particular inequality, we have x minus 7 over x minus 1 is less than 0, or it's negative, this particular expression. Then we can say this can happen in two particular circumstances. The first circumstance is that the numerator is positive and the denominator is negative. And the second circumstance is that the numerator is negative and the denominator is positive. In that case, positive divided by negative would be negative, and the negative divided by positive would be negative. In both cases, it will satisfy this inequality. So now that we have established that, then what we do is we set this up. Okay, so what does it mean for the numerator to be positive? For this to be positive, as I suggested before, that basically means that x minus 7, if it's meant to be positive, must be greater than 0. Correct? And for this inequality to be satisfied, both the numerator must be positive and the denominator must be negative. So x minus 7 must be greater than 0 or positive, and x minus 1 must be less than 0 or negative. The second scenario, the numerator must be negative, x minus 7 must be less than 0, and at the same time or concomitantly, the denominator, x minus 1, must be positive or greater than 0. Now solving these is really easy enough, so you can add 7 to both sides like this, right? So add 7 to both sides, and here you get x must be greater than 7, and here, and at the same time, x add 1 to both sides, you get x must be less than 1. So these are the two scenarios. Now, when we graph this out, remember, let me put a number line over here. So I'm going to graph this particular answer. Because this is an and solution, both of these inequalities must be satisfied. So I'm only putting 1 and 7. I'm only putting numbers of interest here for me because I'm just trying to visualize this answer. X is greater than 7, that's an open circle and going this way. And x is less than 1, that's an open circle and going this way. Now, for this to happen, both of these conditions must be satisfied. And as you can see, there's no way that both of these conditions are going to be satisfied because there's no x that will satisfy both of these conditions. So this, in fact, it does not give us a solution. There's no solution for this particular scenario. Okay? So, well, we can't give up just yet, right? Because we have this other set of inequalities. So if you solve this by adding 7 to both sides, you get x is less than 7, and at the same time, x, add 1 to both sides to solve this one, x must be greater than 7. So, and then if you graph this one, let me graph this over here like this. And I'm just going to again put the numbers of interest for me, 1 and 7. X is open circle less than 7 like this, and x must be greater than 1, open circle like this. Now both of these will carry on and to infinity this way and that way, but this is an and statement, so both of these conditions must be satisfied. So what's common to both of this is everything between 1 and 7. So this works. So the only way this original expression will be true is in the second scenario, because in the first scenario we kind of went into a dead end because there was no solution here, right? And in the second scenario we got this particular answer. So the answer, the solution to this inequality is this over here. So we can say this, the solution is as follows. X is element of all it's a set of element of all numbers that are between 1 and 7. I use this interval notation to express my answer. Now this is not an ordered pair, if you remember. This is this is a representation of the interval 1 and 7 with open ends represented by the parentheses. You can write this as a set notation too, and you can say the solution to this, all right, the solution is a set of all numbers x such that, all right, x is greater than 1 and x is less than 7. So this is an and statement. You can combine this, and those are two different ways of expressing a solution to this original inequality. So that's reasonably easy enough, you say. Let's see if we can try some more trickier questions over here. Now we have a case over here almost similar, but instead of 0 we have a number over here. So the way we solve these is that, as I said, we have to transform this. We have to manipulate the expression so that we have something and 0 on this side and everything is on the other side. So in this case we're going to have to take the 3 on the other side. So I'm going to subtract 3 from both sides like this, okay, and I'm going to write that over here. So you have x plus 32, okay, over x plus 6, right? And then I'm going to subtract the 3 over here like this, and right, I'm going to leave myself a little bit of room over here because I know I have to do some work, is equal to 0 because I've subtracted 3 from both sides. Now I have to combine these two expressions, so I'm going to have to get a common denominator, which is going to be x plus 6. Now we can do this, right? Now don't shy away from fractions. Fractions are your friends, okay? You can't be afraid of fractions for all your life. I mean, that's, because you know they're going to come your way. So master them, all right? Take the time you need to master, and then just take one baby step at a time. Everything turns out okay, anyways, you know. So now you have a common denominator, which is x plus 6. Now I'm going to combine these two. I'm going to add these rational expressions. So that's x plus 6. So I'm just going to copy the x plus 32 because it doesn't have to be multiplied by anything. All right, and then I'm going to write this expression minus, I'm going to distribute this, minus 3x minus 18. And all of this is less than or equal to 0. Well, I can simplify this. I can combine these like terms over here. So I get minus 2x, and then and that's 32 and 18. That's positive 14 divided by x plus 6. So that's x plus 6, and that must equal to, or that must be less than or equal to 0. Now you see I have an expression where I have all of the variables on this side and I have nothing but 0 on the other side. Now that I can see this can happen in two particular scenarios. Now this expression will be less than 0, that is negative. This expression will be negative in two scenarios. Now, again, the numerator could be positive and denominator could be negative. And the second scenario would be the numerator is negative and the denominator is positive. Both of these scenarios will make the whole expression to be less than or equal to 0. So I'm going to set these two up. So the numerator being positive, that's minus 2x plus 14. It has to be positive, right? Greater than or equal to 0. Now remember, I put an equal sign over here because the numerator can be 0. If the numerator is 0, then get 0 over x plus 6, right? And is that less than or equal to 0? Well, 0 divided by x plus 6 is just 0, so you have 0 is less than or equal to 0, and that's a true statement. So the numerator can be 0, so I can write this expression over here with a equal sign along with it. So the numerator being positive, another way of writing that is minus 2x plus 14 is greater than or equal to 0, and at the same time the denominator must be negative. So I'll write that over here, and that's x plus 6 must be negative, less than 0. Now I can't write a 0 less than or equal to over here because the denominator cannot ever be 0. That's like haram. This is super bad. So you can, the denominator is 0 being 0 is not defined. So the one scenario where this inequality will be satisfied is the numerator is positive, the denominator is negative. So I solve this. And then I add negative 14 to both sides. I get minus 14 like this, negative 14 on both sides. Now I divide both sides by negative 2 like this, and I don't make the childish mistake that some children do by forgetting to change the sign over here. So when you multiply, divide an inequality by a negative number, remember you have to flip the sign like this. So this is greater than or equal to becomes less than or equal to. Negative 2 divided by negative 2 is 1, so have x is less than or equal to positive 7. And solving this one over here, subtracting negative 6 from both sides like this, I just get x is less than negative 6. And if I were to graph this on a number line over here, so I'm going to draw a baby number line over here, and I have negative 6 and I have 7. So now I'm just putting the numbers that I need over here, because I kind of need a visual representation over here. When x is less than or equal to 7, that's a closed circle over here and everything over here. And x is less than negative 6, that's the open circle over here, and that's going to go over here like this. Now this is again, this is an AND statement, so both of these have to be satisfied for the solution of these two together. So and that's going to be everything over here, right? So in fact, the solution to both of these, what's common to both of them, or the overlap region for both of them, will be x is going to be equal to less than negative 6. Okay, so that's like first part. So therefore that works. So this will actually satisfy this inequality as well, because that's we generated these two scenarios from original inequality like this. Okay, now let's see what happens when we do this second scenario. The numerator is negative. That's negative 2x plus 14 is negative, meaning it has to be less than or equal to 0. Here it was greater than, here it's going to be less than the second scenario, and the numerator can be 0, so I put an equal sign over there, and I solve this. Before I solve this, I just want to make sure I express, and at the same time, because this is the denominator has to be positive. This is an AND statement. So, and at the same time, the denominator, which is x plus 6, has to be positive, has to be greater than 0. It cannot be equal to 0 again. So solving this, if you subtract 14 from both sides like this, you get minus 2x is less than or equal to negative 14, and then you divide both sides by negative 2. And remembering to change the sign again, because anytime you divide or multiply an inequality by a negative number, you have to change the direction of the inequality. So then we have x is greater than or equal to 7 over here, and here subtracting 6, x is negative 6, like the x is greater than negative 6. Okay, so and then I just have to make sure I check my work, because sometimes when you talk and try to do math at the same time, you can make mistakes. So I have negative 6 over here, and I have 7 over here. X has to be greater than negative 6, and x has to be greater than or equal to negative 7, and to the right like this. And then both of these conditions have to be satisfied again. So we're looking for the overlap, and the overlap will be this. So and that is the overlap. The solution to both of these together is x is greater than or equal to 7. Now 7 is a solution to this, and 7 is also a solution to this. See, because it's going this way here. So this works and this works. So therefore, the final solution to the entirety of the problem, is this and this. So the solution to this inequality is the set of number x, or the x is an element of the following intervals. X is an element of this particular set. Now, how do we express this inequality? Well, it starts from here and goes forever over here, right? So open end over here, that's parentheses, from negative infinity all the way up to negative 6, and that's a open end also, therefore parentheses. And you can say or, because it can be this, or it can be this, right? So this is an or statement, okay? And or x is an element of this set. Now this is a closed end, so it's going to be 7 over here. This is square bracket, and it keeps on going to positive infinity forever like this, and that's open end because you can't contain the infinity. Another way of expressing, a cooler way of expressing this same thing is saying like this: x is an element of this interval, minus 6, and combining with, because you can combine these two, or and union of these two particular sets. It's from close bracket 7 going to positive infinity like this. Now this symbol that I have written over here, okay, that's a union symbol. That's a union of two sets. It's a combining of two sets. And this symbol upside down U would be the intersection of two sets. I haven't formally talked to you about this, but inshallah in the future we will talk about this again. So that's so this is a solution to this problem over here. Another way of expressing this solution is using the set notation. The solution to this inequality is a set of all number x such that, okay, x is less than, it's not equal to -6, it's just less than -6, or x is greater than or equal to 7. So that's another way of expressing the solution to this inequality. Well, let's see if we can do some more exciting problems like this. Well, this is very interesting here. Now, whoa, what are you going to do? Well, now you say, well, now we have like 3 things, and all of these, when they multiply, have to be greater than 0 or positive. So we're looking for positive products here, right? So, well, we have 3 things here. Well, how are we going to get a positive product? Well, here's some potential. So here's a positive and positive. All of them could be positive like this, right? If you multiply 3 positive numbers, you can get a positive, right? Or it's possible that the 2 numerators are negative and the denominator is positive, right? Or one of the numerators could be positive like this and the denominator is negative, and then you would get a positive. Well, it's getting kind of complicated, right? Well, it turns out there's an easier way of solving this type of inequalities, and in fact you can use the same following method to solve the previous questions, and it's actually much easier. And you say, why didn't you teach the easy method first? Well, first we have to understand the concept, because if I taught you this before without explaining what I did before, you might not understand what I'm going to tell you now. So the idea here is as follows. What you do is you find what's called critical values, or some people call it critical points, okay, whatever you like to call it. You find the critical point, which are basically, these are the zeros. These are the zeros of the numerator and the zeros of the denominator. So basically you find the zeros of the numerator, zeros of the denominator. In other words, you find whatever makes the numerator 0, and you find whatever makes the denominator 0. And then what you do is you take the friendly neighborhood number line, okay, and then you place those critical points or critical values on the number line. So let's do this one step at a time. So let's find all the critical values of the numerator here, okay? So for the numerator, we want x plus 3. We want to see what makes the numerator 0, see? We want this product, okay, to be equal to 0. We want to find out what. Well, that's easy enough in this case because it's already factored out for us. We use 0 product property, and you divide this into 2 equations. X plus 3 is equal to 0, or x from 0 product property, x plus 5 is equal to 0. Right? X plus 5 equals to 0. And solving this, you get x is equal to -3, or x is equal to -5. That was easy enough. So we found our zeros for the numerators. X equals -3, x equals -5. Those are the zeros for the numerator. Finding the zeros for the denominator is easy peasy, as you can see over here. That is what makes the denominator 0. It's -2. Well, that's easy enough, right? So the zeros for the denominator, well, let's just do it formally, because x, we're going to set this to denominator. It's not always going to be that easy, right? And then x is equal to -2. So there it is. So we found the zeros of the numerator, and we found the zeros of the denominator, everything that makes it negative. There we go. And then what do we do with that? Well, what are we going to do with that? We're going to put it on the number line, okay? So I'm just going to put these points in the number line relative to each other, and I really don't care about the distance between them, because That's not really the point here. So you can do a more methodical job if you wanted to, but that's what I'm going to do over here. Now you understand there's a slight difference between the zeros of the numerator and the zero of the denominator. See, the -2 is never a solution to this inequality, right? Because you put a -2 in there, like bad things happen, right? You know, there's like really bad things happen. So the denominator is 0, so -2 is never a solution to this inequality. However, the -3 and -5 are solutions to this particular, they're going to be closed circles. Now, so the three critical values, you plot them on the number line like this. Now, I request when you actually do the actual number line, you should, maybe I should have set a better example for you, but inshallah next time I'll try to do that. You should do it properly, you know, make a proper number line. So when you find the critical values, you plot them on the number line, understanding that the zeros of the denominator will be open circle and they're not the solution for the inequalities. The zeros for the numerator may be, because let's see, if you put a -3 in there, see, if you put the -3 in the numerator, -3 over here, -3 over here, and -3 over here, okay, if you substitute -3 in the expression, what you will get is 0 and times 2 over like -1. The whole thing will be it will be 0, right? So if you substitute -3 in the inequality, you get 0 is greater than or equal to 0. But that's a true statement. Although 0 is not greater than 0, certainly is equal to 0 the last time I checked, right? So -3 is in fact a solution to the inequality. In the same way, -5 is a solution to the inequality, because if you put a -5 over here, this turns 0, the whole expression turns 0, then you still get 0 is greater than or equal to 0. And that is a true statement. So both -3 and -5 are actually solutions to the inequality. Okay, so we did that. So we found out the critical values. Then all you gotta do is, see, you gotta pick a point from all the intervals here. First, understand that when you put the critical values on the number line, you kind of divide up the number line into different segments or different intervals. There's one interval here, and there's one here in between -3 and -5. There's another one here, and there's another one here. So you kind of divvy up the number line into these 4 different intervals, right? Okay, so you check one interval at a time. Let's see if you check some number over here. What's a convenient number over there? I don't know. 0 stands out to me. It's kind of like staring at me. So if you check, let's say 0, if you check any number over here, and if it works out, and that means every number here is going to work. Okay, if one number works, then every number, and if 0 does not work, then no number here is going to work. So all you got to do is you got to pick a point here and check it, and if it works, everything's going to work. And then you got to pick a point between here and see if it works, and you got to pick a point between here and here, and then you got it. Okay, so that's what we're going to do. So let's try 0 first. Let's see if you put a 0 over here. I'm just going to put it here. Then you get like 3. 0 plus 3 is 3, and 0 plus 5 is 5, and then you get 2 on the bottom. Now, you don't have to solve the whole thing, see. All you're looking to see if it is a positive number or not. So you don't have to sweat and try to find your calculator or something like that. All you're looking to see if it's a positive number or not, right? So, well, this is positive, this is positive, and this is positive, right? All these are positive numbers, so the product of 3 positive numbers is going to be positive. So if you put a 0 over here, you get 3, 5, and 2, and that's a positive product. So everything here, in fact, is going to be a solution. So 0 works, so everything here is also going to work. Okay, that's pretty good. So let's try a number between -3 and -2. Let's try -2.5. If you put -2.5 over here, you don't have to even do that. You can say, well, this is going to be a positive, and this is going to be a positive, and this is going to be a negative. If you can do that, great. But if you can't do that, you can do the math if you want to. -2.5 plus 3 is like 0.5. That's positive, and that's 2.5 over here, and that's -0.5 over here. Either way you do it, you have a positive, a negative in the denominator. It ends up being a negative number. and that certainly is not greater than 0. So the negative 2.5 does not work. So nothing that's between negative 3 and 2 will work. So this interval is not a solution. Well, how about something in here? So let's try negative 4. If you put negative 4 in there, and I'm just putting negative 4 in every place x is going to be. So that's going to be negative 1 and 1 over negative 2. This is negative number here divided by negative. That's a positive number. So actually that works out. So negative 4 is the solution for this inequality. So everything here is going to be a solution. All right. Now you can probably guess that's not going to work. You can try any number. You can try negative 100. I'm just going to try negative 10. If you put negative 10 everywhere, okay. So negative 10. That's going to be a negative number. That's going to be a negative number. And that's going to be a negative number, right? So that's going to be negative times negative positive, and the denominator is negative. So the whole thing is going to be negative. And negative, so we have a greater than sign, so it's not going to work. So this side is not going to work. So the solution to this inequality, as you can see, are those two intervals that I have drawn here on the number line. So you can write the solution as this. X is an element of this particular interval, negative 5 and negative 3. And also this interval, you can write with the union, or x is an element of this, negative 2, and it's goes to positive infinity like this. Okay, you can write it like this if you like, or you can just use the set notation. The solution is a set of all x such that x is greater than or equal to negative 5 and less than or equal to negative 2. You can combine that too, or x is greater than negative 2. So that's a set notation. So these are different ways of writing the answer to this particular inequality. Okay, let's see what else we got. Now this is an interesting question. See, now what do we do over here? This one is slightly different because here we have a unfactored quadratic expression. Trinomial, right? Well, second degree polynomial function. See, you can't get away from this factoring. So here we're going to have to factor. See, x squared minus 5x minus 24. So as I said, you can't like escape from factoring in your mathematical career. So you might as well master this technique now. You know what I'm saying? So if you take any math class in the future, and I hope you do, just for the love of it, you have to factor. You know what I'm saying? So you might as well learn it now. So the way you factor is, okay, it's going to be x, it's going to be x, and then here you write all the potential factors of 24. That's 1 and 24, and 2 and 12, and 3 and 8, and 4 and 6. Okay, now these potential factors, the candidates, is what's going to land over here in these two spots, right? And then the product of those would have to add or subtract to give the 5x. Okay, so see, when you're foiling, F-O-I-L, the first, outer, inner, last products, that's what that stands for. Okay, so the first and outer, inner, last products, the outer and inner products, that's this product and this product, these two add or subtract to give the middle term of the trinomial. So the oi in the FOIL is the middle term when you combine the two products. Okay, so we have to find we have to choose one of these. All right, so such that they add or subtract and give 5. Well, you know, it's going to be 8 and 3. You know, if you do enough of these, it becomes pretty natural. So it's going to be 3 and 8. Now all we have to do is we have to figure out the signs, and that's not that difficult. This one being negative, it tells that the two signs that go over here are going to be different, right? And this negative sign here tells us that the bigger product is going to be negative. Well, the bigger product is 8x, okay, and that's going to be negative. So what we're going to have to do is we're going to have to put a negative sign. I'm going to put a negative 8 over here and a positive 3 over here. Okay, because then the bigger product is negative 8x, and they'll add up to this. So this is how you factor this particular expression. So I'm going to rewrite this as x plus 6 over x squared minus 5x minus 24. Sorry, I'm just rewrote the whole thing. I meant to write the factored form. That's x plus 3 and x minus 8 like this, and this has to be greater than equal to 0, right? And now it's similar to the problem that we have talked about before. You then find the critical values. The critical values will be the CRITIC, critical values or critical points will be the zeros of the numerator and the zeros of the denominator, and that -6 and -3 and 8, and you plot those, and then you do something like we did before. Not too difficult, right? The last example I'd like to share with you before I finish in a similar way is this question. See, and here we have one rational expression here, one rational expression on the other side of the divide of the inequality. In this case, again, I have to bring one of these to the other side. I'm going to bring this to the other side. So I have one side with all expressions and nothing but 0 on the other side. So I have -3 over here, and I have x plus 7 over here. And I add this to both sides, and I get like this. And then I get like 4 over x plus 8. And then see, because I just took the whole thing to the side, and less than or equal to 0 like this. Now I have 0 here, right? And I have everything else on this side. And then we have to combine these two. We have to get a common denominator, and that's easy peasy. It's x plus 7 and x plus 8, like this. And then I have to multiply this one by x plus 8. And I have to multiply this one by x plus 7. Right? And all of this has to be less than or equal to 0. And then I'm going to rewrite this here. I have -3 times the quantity x plus 8. And I have plus 4 times the quantity x plus 7. Okay? Now you can distribute these like this, and then combine like terms, and then what you will have is the denominator will be x plus 7 and x plus 8, right? And this is -3x, and this is minus 24, right? Is that correct? So, and this is 4x plus 28 if I did all this correct. And I can combine these like terms. I get x, and then plus, sorry, x plus, these two combine, x plus 4 if I did everything correct. Now we're in the same boat again. I find the critical values by finding the zeros of the numerator and finding the zeros of the denominator, and I plot those, and I which divides my number line into different segments, different intervals, and I check each segment to see if it's a solution or not. And that's pretty much it to solving rational inequalities, and I hope you enjoyed, and I hope you mastered this topic, and this actually concludes all the material for chapter 5 for us. Until next time, assalatu wassalamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.